We saw earlier that information can be stored by magnetizing very small regions of a hard disk or some other storage medium. Each of these regions corresponds to one unit of information called a bit. If we want to store more data in a smaller device, we have to reduce the size of these regions. Magnetic regions are each composed of small, densely packed particles called grains. If we make the grains smaller, the magnetic regions get smaller too, but if we try to make them too small, we run into an obstacle. Ambient heat causes atoms and small particles to constantly and randomly vibrate. It's possible for a very small grain to pick up enough energy from these vibrations to reverse the direction of its magnetic field. The smaller the particles, the more likely this is to happen. This is called the Superparamagnetic effect, and it's a big problem for really tiny grains. If enough of the grains in a magnetic region get knocked around, the whole region may change its polarity. This causes the value of the bit to change between 1 and a 0, which is called bit flipping. The density of the information on the disk is limited by the size of the magnetic regions. This, in turn, is limited by how small we can make the grains before they become vulnerable to the superparamagnetic effect, which cause bit flipping. Right now, magnetic memory, like the hard drive in your computer, is limited to about 19 gigabytes per square inch. If we could reduce the surface area without reducing the volume of the individual magnetic regions, we could fit more of them into a smaller disk and store information in less space. This is done by replacing the flat magnetic regions with densely packed vertical cylinders on the disk. Each cylinder represents one bit. The goal is to increase their height while keeping their cross-section as small as possible. This way, the magnetic regions have enough volume to keep them stable while still presenting a small surface area to the read head. For this to work, the cylinders have to be very small and precisely arranged.